Mathematics at Boise State. Welcome to Bronco Day. Feel free, I think everyone has said their name, hometown, and their high school mascot, but maybe you didn't hear each other, so feel free to drop that in chat while I'm talking. And feel free to interrupt if you have any questions. I don't mind. Just speak up and I'll do my best to answer.
Just so you know, we don't have a mascot. We're kind of independent learning. So
we have to come up with a mascot for you. Your mascot could be the mathematician. Okay.
my mascots are snakes, so.
Okay, welcome to Online Bronco Day. I'll talk about a few topics, including why math and math pays, that means careers, and why Boise State University is a great place to study math. I'll talk about our community of learners and the kinds of math that we have here. It's a really broad range. And I'll talk at the end about something we mentioned before, which is doing research with faculty. So start with a math puzzle. It's just a little game. Here you see 16 shapes, circles, hearts, triangles, and squares, and 16 squares to put them in. Do you think we can put all 16 of them in there with one in each row and column?
Yes, and that is very easy to do. I've already figured it out.
How many ways can you do it? Can you come up with another solution?
Mm-hmm.
Or is there only one way?
No, there's many ways.
Can you come up with, how many ways?
I can only think of 6. But there might be more.
There might be more. There's 576 ways. I didn't count them all. I looked it up on Wikipedia, so I cheated. 576. What if there was 5 by 5?
That would be many more.
There would be more. What if there was 6 by 6?
A lot more.
A lot more. Up to a few hundred or so people know. But at some point, people haven't actually worked out these numbers for how many ways there are to fill this out. So these are called Latin squares. And it's kind of up in the air. There are formulas, but the formulas are too complicated. And people haven't been able to compute these numbers. So it's just a math puzzle. Maybe we'll have some more puzzles and games a little bit later on. Okay. Let's do that. Math pays in more ways than you think. Sometimes people worry about careers, but you shouldn't worry about careers. Math is great for careers. It opens up a lot of options, a broad range of options. According to Department of Labor information, 8 out of the top 10 careers are math intensive. And so math is a great preparation for them. Math majors report high job satisfaction. And there's a wide range of pure and applied subjects. Here's a little cartoon showing many different types of pure math, applied math. And that's, statistics is there. That's a huge area that's very important, as you can imagine. That little puzzle we did, well, maybe I skipped over it a little bit, but that puzzle of counting how many ways, that would fall into the area of pure math that's usually referred to as combinatorics, because it means counting how many combinations. So that's here sort of in the middle. I lost it there, combinatorics. And where do people with math degrees go to work? Well, lots of places. Of course, it's famous to become a math teacher and teach at a school, but people might not realize how many other options there are, like working in industry. A lot of companies have mathematicians to support their research. Right now, this is huge at tech companies like Facebook, Microsoft, Apple. They have entire divisions of math-intensive researchers who are studying artificial intelligence, data science, computer vision, Tesla, and the driverless cars. This is all very mathematical. They take a lot of mathematicians. The government agencies and laboratories take a lot of mathematicians. So in the government, there are divisions like weather forecasting, the NOAA, National Oceanic and Atmospheric Administration.
Yep.
The NSO, the National Satellite Observations. Oh, what's this acronym?
I don't know, but if you had the topic of agencies,
NRO.
national agencies, and NRL, yeah, so that's Navy Research Lab. There's a bunch of them, and I actually collaborate with a bunch of them as well. So there's absolutely a big pool for good mathematicians to work at those places. And the applications range from what you say, weather through, climate is a big topic these days, but also nuclear sciences, all kinds of different sciences, and they all require math background. So absolutely,
Satellites.
it's a big, yeah.
NASA, the census, the Bureau of Labor Statistics, economic things at the Fed, and of course, the biggest of them all is the National Security Agency that takes mathematicians to work on cryptography things. So tons of math stuff in the government. That was focused on the federal government, but there's much more. So for example, there's the national labs that are all over the country. We have one in Idaho. The Idaho National Lab in Idaho Falls takes mathematicians who work with the scientists there to support their research. There's a tremendous range of careers in mathematics. It's just amazing. Okay. Our students love Boise State, and they're some of the things that they're happy about. We try to make Boise State and the math department feel like a home away from home. We're very welcoming. One of the things that I like about the math department is that anytime, except the last few weeks, but when we're on campus, just any time of day, there's always other people around who are happy to talk and have a friendly conversation. And as a student, I feel like you can just walk around and find professors who are generous with their time and happy to talk to students about their research or about what's going on in mathematics. I always encourage my students, if they're looking for a thesis advisor or something like that, I encourage them to just go visit all the faculty and just say, can I take 5 minutes of your time and tell me what kind of math are you interested in? And all the faculty really are welcoming to that kind of connections with students. Boise State is affordable. There are lots of research and career opportunities. I'll talk more about the math research opportunities a little bit later on. And we, in the math department, support innovative, high quality teaching. We do all kinds of things, including project-based learning, flipped classroom learning, service learning. We really take teaching seriously as a department, and we value it, and we work hard to be good teachers. Well, we're not only about teachers, we're about learners. This is a picture from a class. I don't know if my faculty colleagues know which class this is from. This is from my class. This is from my Math 187 class a few years ago. So I had students, it may be a little bit hard to see, they're using kind of faint markers, but they were doing claims like, if x is an integer such that 3x squared minus 2x plus 5 is odd, then x is even. So some even odd patterns and studying logic. So I had them doing some of these problems on the board.
They're smiling, so it must have been good.
Yeah. By the way, 2 of these students were computer science majors who were getting minors in applied mathematics. And one of them was studying just regular mathematics. So yeah, so we have lots of students in our classes, and we enjoy working with a range of students. Some of the things we do to support our community of learners is we have a great math club that meets and has student-oriented math talks. So just sort of sharing cool topics. They were this close to taking a road trip to a math conference in Salt Lake City, but then everything got shut down all of a sudden. That would have been just about three or 4 weeks ago. But you know, maybe in the fall they'll be able to plan another trip. We'll see. So they were going to have a road trip adventure and go to a math conference together as students. We have a tutoring center set up in one of the computer labs. So there's multiple tutoring support systems on campus. There's one run by the Math Learning Center that's oriented at the more intro level classes up through roughly calculus. And then we have a separate tutoring room that helps students with classes from calculus up, including the upper division math classes. So we support students in those ways. Oh, and I guess I should say, take classes from instructors who care. Yeah, all of us are really passionate about teaching and enjoy working with students. And one advantage of Boise State is that in the upper level math classes, they tend to be more smaller size, so you get a closer connection with your instructor. At some universities, you know, you have classes that even right up into your junior and senior year, you're in a 100-person class. But at Boise State, you get into classes that have 30, 20, maybe even 15 students, you know, and so you get a lot more chance to actually work with your teacher, and they get to know who you are and support you individually, and you're not just a face in the crowd in Boise State mathematics. So what kind of math do we have at Boise State? In these slides, we're breaking it down into 3 main categories. Math education is a big part of what we do. So this is aimed at understanding how people learn math and how we can support their learning. So our faculty, like Dr. Cavey, actually do research on this and run studies of how people learn to understand different parts of math. For example, Dr. Sasha Wong studies how students understand geometry, what are the misconceptions, and how can we help people overcome those misconceptions. That kind of thing. And we work with students who are interested in becoming, the center target is secondary level math teachers. That means high school math teachers. But we work with students who want to go into junior high, and we even have work with primary level teachers. And on the other side of the spectrum, people who want to be college teachers. Our program is a good start on that path too. We have a program called I Do Teach. ID is for Idaho, you know, and one of the people who helped develop and launch that program is Dr. Lori Cavey, who's right here with us. Lori, I don't know if you want to say anything.
I certainly can. I'm trying to monitor our guests. We've had a few additional people show up in the last few minutes, so
Welcome.
Just been trying to make sure that they all feel welcome and all of that. But yes, the I Do Teach program is a program that's modeled after the You Teach program at University of Texas, Austin. And it's specially designed for people who are interested in teaching in the STEM areas. So science, technology, engineering, and mathematics. And one of the hallmarks of that program is that we have education courses that are designed specifically for people who are teaching in those content areas instead of what you typically find in education programs, which is more general education type content. So we have that, plus in the math department specifically, we offer a handful of math courses that are designed specifically for the future teacher in mind, that is designed to help you really learn the ins and outs of the ideas that ideally you hope to help your future students understand well. One other thing I might mention about the I Do Teach program is that we have ongoing support from the National Science Foundation to provide scholarships for people who are interested in teaching. Right now, the focus is supporting people who are interested in teaching in rural areas, but this is a great scholarship program that's available to people who are juniors and seniors in college. It will completely cover all of your expenses for education for those last 2 years, and the commitment is to teach 1 year for every semester that you get the scholarship support. So it's a fairly great opportunity, I would say, to be able to get your education paid for and at the same time pay back in a way that contributes to the larger community.
Thanks, Lori or Dr. Katie. The I Do Teach program is just great. Students in the I Do Teach program will get to visit classrooms right from the very first semester that they're in there. It's not one of these programs where you spend 2-3 years taking harder and harder classes, and then at the end, for the first time, they let you step into a classroom. No, right from the very beginning, you're going into a classroom and working with students, and you teach a lesson and then visit later and teach another lesson. So you get a chance right from the beginning to try it out and see how you feel and to get really excited about teaching. It's a great program. Another important point to bring up is that our faculty in the math department at Boise State work with the high school math programs at a lot of school districts in the area. And so we connect with those high school programs all over Southeast Idaho and help our students find placements. Let me move forward. In pure math, that's me, we study ideas, patterns, If you were here at the beginning of the presentation, you saw this combinatorics puzzle, but there's much more. Some of the areas of expertise in pure mathematics include set theory and logic, the foundations of math, the foundations of how do we know what we know, topology, knots and groups. After the presentation, maybe we'll play a little topology game on the Zoom screen. Algebraic geometry and combinatorics. I'm interested in algebraic geometry and combinatorics. Algebraic geometry starts with a pretty basic idea. If you have a shape like a circle, you could describe that by an equation like x squared plus y squared equals 1. Or a different shape like a parabola might be a different equation like y equals x squared. And so now you have a bridge back and forth between geometry and algebra. And if you have a geometry problem, you could try to translate it into the equations and use algebra to solve it. And if you have an algebra problem, you could interpret those as equations and try to translate it into geometry and use geometry to solve it. So it's a translation tool to help solve problems on both sides of that bridge. And that's what I do, and I think it's fun. I'm biased. And cryptology, we also have faculty who work on cryptology, and they actually collaborate with other faculty at other Idaho institutions and Idaho National Labs and at the NSA. So that's a very exciting part of our program. I haven't been pausing to see if anybody has questions. If you have questions, feel free to jump in and speak or type a question in chat. We go forward. And then one more big, super energetic area of our department is applied math and statistics. And Dr. Michal Kopera is one of our computational and applied mathematicians. You can imagine that this is a very in-demand part of mathematics. We were saying before that a lot of companies, government agencies, everybody's interested in applied math for good reason. It's important stuff, and it's really cool. Michal, I don't know, do you want to say anything?
Sure, I can jump in real quick. So you mentioned that, you know, it's very timely, and indeed, like some of our faculty, Dr. Jody Mead was involved in creating a model for coronavirus for Idaho, for instance, on a very short notice. So that you can imagine how important and timely problems we solve. But in the longer run, I mean, I can talk about my research a little bit. So what I do, for instance, I'm just starting a new project where we're going to be developing a new model for the U.S. Navy. So we are going to use equations to model the movement of the water in the ocean. And the end goal of this project is to provide a model, a computer program, which the Navy will use for their forecasting purposes and operational purposes. So that's pretty exciting because on one hand, we solve mathematics problems. On the other hand, those things are being applied and used to, help people and help our country prosper, right? So that's one example of what we do. But you can see on this slide, there's a bunch of other applications like fluid dynamics is what I do mostly. But the same equations that describe movement of the ocean is also can be also applied to, say, aerodynamics of a car, stuff like that. And then you can see a bunch of other applications like data science is a big thing these days because we generate a lot of data as a society, and we can learn a lot of things using just that data. So that's a very, very timely topic as well. You see below there's also some imaging. So there's a lot of questions. Dr. Jody Mead, whom I mentioned before, is also working a lot on this aspect of the problem because it's not so easy to just take an X-ray or take a MRI image of something. There's a lot of math that go into translating what the machine receives and what signals the machine receives before it can actually generate the image. So it's not trivial. It's not just like, you get a photo and that's it. There's a lot of math that goes into that. Finally, faculty in our department also do a lot of stuff related to climate change and geophysics in general. We have at least 2-3 faculty who work on models regarding different aspects of climate related applications, and I myself included. So there's faculty working on atmospheric applications, ocean applications, different stuff along this way. And so I'm looking on this slide real quick. Of course, there's a lot of statistics research going on, but I cannot speak to that much. Apologies for that. Maybe Zach can tell you more. But
So
a big
for
part of
example-
say.
Oh, go ahead.
So a big part, and so what we do is, as I mentioned in the beginning, is not only we do mathematics, but we typically implement, at least speaking for myself, we implement this mathematics as a computer program, and then are able to solve various scenarios and predict various scenarios how they develop using computer programs. So programming is a big part of what we do, and not only programming itself, but also there's a whole area of mathematics called numerical methods. So how to translate equations into methods which can be then implemented in a computer. So that's very, very exciting area of research. And I've noticed that the previous slides, there was the linear algebra was put under pure math, but I would say it's one of the tools we use a lot on a daily basis as applied mathematicians. So there are definitely connections between, there's not a strong divide between pure and applied mathematics, but there is something to be learned from, I guess, sort of across the fence, right? We use a lot of linear algebra, differential equations, and stuff like that in our work. So I guess that's about it. I'm happy to discuss it further at the end of the presentation if you guys have any questions.
Does anybody have any questions right now? Not yet. One of our faculty, Dr. Jae-Chul Lee, is an expert on time series analysis. And a good example of a time series is just any series of measurements over time, such as daily rainfall totals, say. So you have daily rainfall totals in certain locations that stretch back 100 years or more. And you can look at that record and try to see, has the climate changed? What's going on there? And he's an expert on analysis of that kind of data that's in a time series structure. Dr. Leming Chu is an expert on wavelet analysis and wavelets. So that's an important part of compression and statistics. Dr. Grady Wright, one of our faculty, is an expert on numerical methods that Michal mentioned. And he both develops new methods that can be used for anything somebody wants to compute, but he also uses those methods to do research. In his case, I believe his primary interest is on geophysical things or atmospheric things like winds and jet streams and so on.
Well, if I can cut in, recently actually we started working with Dr. Wright on some biomedical, biochemical applications, biophysical applications. So modeling of say how the cells interact with their environment. And this is pretty exciting because it takes the numerical methods to a new level and puts a lot of new requirements to further develop those methods so they can handle those very different situations. So very exciting direction.
It's hard enough dealing with the Earth, which is more or less a sphere, and then you start talking about a cell, which is wobbly.
Exactly right. That's exactly what I'm talking about. That we need to push our methods to be able to go from a sphere to a wobbly sphere, or a sphere which is changing shape as time passes, right? So that's whole new area.
And that's what's happening at Boise State Math. Lots of exciting, dynamic things, all kinds of new developments going on all the time, and we bring students in on those kinds of projects. One more comment was that there's not that much separation between pure math and applied math. I think I agree with that. I mentioned algebraic geometry as a pure thing. As a pure mathematician, I think about the mathematical problem first and applications second. That doesn't mean that there aren't applications. but maybe that's a story for later. Let me go forward here. And, okay. So this has been said a few times that we love working with students on our research, and we have lots of different projects that students are involved in. In applied math and statistics, they work with students. Students learn programming and data science. In pure math, we do research with students on cryptology and set theory and lots of things. I just finished writing a paper with an undergraduate student, and it's been submitted to a journal just a week ago. So pretty exciting. And in education, they certainly work with students on research projects. So for instance, Dr. Cavey has a major project called VCAST, which is in collaboration with a dozen or more universities across the country. I can't keep count. It's led from here at Boise State, and it has student researchers involved who help develop materials for the project. Dr. Cavey, or can I point to you and ask you to comment on that?
Sure. The project that VCAST is centered around is developing some online curriculum materials for people who want to be teachers. So it's somewhat connected to our I Do Teach program that I spoke about a few minutes ago. But because I Do Teach is connected to the UTeach program, which is now being replicated at over 50 universities across the country, we have the opportunity to share, pilot, and get feedback on the materials that we've been developing at a bunch of different universities across the country. The main impetus for the project is to find ways to help future teachers better understand the way real students think about important mathematical ideas.
All right, thanks.
Mm-hmm.
Lots of exciting opportunities at Boise State. And finally, we also have an accelerated master's degree program that in 5 years, you can complete the bachelor's degree and master's degree together in a single 5-year process. Lots of opportunities. I hope that you enjoyed hearing about math at Boise State, and we love to hear what questions you might have.
Well, for what it's worth, if you want to learn computer science, we also do teach a lot of programming with mathematical mindset. So you might want to consider, also looking at this from this perspective. That we teach programming, which is specifically geared towards solving equations and creating models and making predictions and working with data, right? In computer science department, you will get a different flavor of that. You will get more programming oriented on like application development, databases, stuff like that. So yeah, there's a lot to explore at Boise State.